Welcome to March 11th LeetCode Challenge. Rotate list. Given the head of a linked list, rotate the list to the right by k places. So we're given the example number 1 of a linked list here, and we want to rotate it. So rotate one time, where you rotate basically the 5 goes in the front, rotate it again, the 4 goes in the front. So given k places, that's how many times we basically do a right shift of the linked list, basically. So given the example, we have a linked list containing 3 values, 0, 1, 2, and we're given k equals to 4. So we would shift it once, where the 2 goes in the front, everything is shifted to the right. Shift it again a second time, the 1 goes in the front, everything is shifted to the right. Third time, 0 goes to the front, so we're back to the original list. So notice how that if we take the modulus of the size of the linked list to begin with, we get the same list to begin with. And then we rotate it one more time, right, where we get the first rotation again. So in order to prevent, well, that's an idea. I mean, an idea would be basically take the modulus, or whatever we need to do is just rotate within the length of the linked list, so we don't have to go through many iterations of it, just to save some time and space. Some time, I should say. The number of the nodes of the linked list range between 0 to 500, value of the nodes between negative 100 to 100, and k is between 0 and 2 times 10 to the 9. Alright, so essentially what I'm thinking, I mean, might not be the most efficient route to go and solve this, but essentially let's turn this linked list into a stack, and then rebuild it using the head. That's pretty much it, using a stack method. Might not be the most efficient, but it'll work, I think. So first thing I want to do is node is assigned to head, and then we want to develop a stack, and that's going to be our course list value. And then we'll rule out the base case. So if head is equal to none, return none. Oops, none. Next thing you want to do is turn the linked list into a stack. So basically iterate through each node in the linked list and put it inside and append it to the stack. So while node is not equal to none, we're going to append it to the stack. So append the node to the stack. And then we want to go to the next node. So node equals node.next. So that's pretty simple for that aspect. So we convert the linked list into a stack. So let's say now we have that. Next we're given k. So notice how if we're given k of the length greater than the size of the linked list, then we could just take the modulus of that. So let's do that. So if k is greater than or equal to the length of the stack, we are going to take the modulus of k and reassign it back to k. So it'll be k equals that, length of the stack. So we're done that part. Next thing we want to do next is reduce the stack by k amount, and then pop off the nodes as they appear in the new linked list. So essentially we're going to rebuild the linked list. So while k is greater than 1 or 0, we are going to rebuild the stack. So we have the first thing we want to do is decrement k values, k by 1. So we want is say the old node or old head assigned to head. So we're gonna have a pointer there instead of calling call old head. Call it temp. Well, temp is equal to head. Head is going to be assigned to the stack.pop value. So stack.pop is the node of the stack that we put in, and then head.next will be equal to the temp variable. Next will be assigned to temp. So we kind of need that temp pointer to the head, and we want to reassign it all of a sudden. So this keeps on iterating through until k becomes greater than 0. less than 0. Whenever this condition is false, basically. And then what we want to do next is exit this while loop, and then we want to eliminate the cycles. So after the cycles are done, what we want to do next is return the stack of -1 dot next, and we want to basically put the last pointer pointing to none as well, and that's pretty much it. Return, since we altered the original head linked list, we just altered it so that we just return it back so we don't use any additional space. Let's run this. Looks somewhat decent. Let's submit it. Alright, accepted. So time complexity is big O of n. Yeah, because we have a while loop here, another while loop here, but k could be of size k. Let's see the length. Well, yeah, well, we take the modulus of it, which is pretty good. So big O of n, where n is the size of the linked list. Time complexity, or space complexity, I should say. Oh. Space complexity is we alter head only, so it'd be constant space. But let's see, this isn't very good, but it'll work. Alright, have a great day, guys.